Thanks, Ken. And I'm not going to take it personally that Ken mentioned a couple times where the coffee is before I get started speaking and put you to sleep. No, I'm just kidding. Hopefully, this is going to be a fun session. So my focus is going to be, as Ken mentioned, on using coding a way to sort of use AI, generative AI, as a pair programmer or an assistant for you in your coding practices. What I have seen with playing around with the tools that we have available is that you do need to be slightly aware of what prompts you use. You have to be slightly aware of what kinds of feedback it gives you. It's not foolproof. And so I'm going to actually show you some negative examples of where generative AI can fail as well. I am actually going to speak a little bit about the ethical implications of using these kinds of generative AI tools to generate your own code that you might use in your research as well. But if there are any questions, I'm also happy to pause and take them. So I should introduce myself. I'm a faculty member in the Computer Science and Engineering Division of the Electrical Engineering and Computer Science Department in the College of Engineering. I teach the machine learning course. It's one of our largest undergraduate courses. It's an upper-level course. We have a few various sort of courses in the AI sphere. But what I'm going to be focusing on today is actually thinking about not the coding so much as what we can do with the coding. So we want to remove ourselves as far as possible from the coding aspect, do as little typing as possible, keep the focus to the high level sort of ideas first before sort of, and so that, we don't have to do the sort of nitty-gritty coding. And I'll show you different ways in which we can actually use the generative AI tool to also explain the code that it has generated. So it's a little meta as well. So I'll be co-running this session with Xuan, who is going to focus on slightly different aspects of using generative AI for coding purposes. And so my part of this is going to be divided into three main parts. So I want to say a little bit, I do come from the ML side, so I want to say a little bit about how this particular tool came to be. I'm going to keep it fairly at a level where we are interested in actually using this tool as opposed to the, under the hood view of the transformer and so on. And then I'm going to use GitHub Pilot as a microcosm of a way to use generative AI more broadly for coding purposes. This is going to be my part of the session. Xuan is going to focus on slightly different tools to do effectively the same sorts of things. So you can sort of see two different processes. One good thing about using GitHub Copilot, with some caveats, which I'll talk about, is that we have access to it as people who are affiliated with U of M, which is not universally true. I will talk a little bit about how to get started with installation of an interesting IDE, which I think is fairly easy to use and intuitive to use, called PyCharm, and then how to integrate that with GitHub Copilot, as well as how we can use Jupyter Notebooks. And if you haven't seen Jupyter Notebooks before, you're in for a treat. If you have seen it, you know that this is actually a very useful way of sort of understanding the data that you have access to. So my focus is mainly going to be sort of data analysis and data visualization, and then some machine learning as well. And then I do want to say that there are a few tools that are out there. First, they're just sort of being rolled out. I tried out a couple of those tools. I wasn't very impressed, but I'm still going to tell you because that's sort of upcoming. Some of these tools, take some time to sort of develop and really mature. So, all right. So if that sounds good, I am going to proceed with my prologue. So all of this sort of started with OpenAI's GPT model. GPT was an interesting model because what they did was they sort of notice the folks at OpenAI notice that we have these large corpuses of unlabeled data. This is actually true just in general in machine learning. Getting labeled data is fairly expensive, especially getting reliable labeled data is fairly expensive. What they did was this if you're interested in the technical aspect, in the machine learning technical aspect, it was a semi-supervised learning model. So what they did was they took this large corpus of unlabeled data. They had a supervised learning model, so a model that sort of used labeled data, and then they used that to sort of fine-tune the model that they learned. And back in 2018, they proposed this 110 million parameter model, which seemed to do really well with respect to the task that it was. They had sort of a table with comparisons across the board. And then in 2019, they they modified their original model. So any guesses on what this next model was called? So the first model was GPT. It's very creative. It was called GPT-2. So GPT-2 had even more parameters. How many more parameters? 1.5 billion more parameters. So each of these parameters is essentially sort of encoding some notion of complexity of the model. So, it's not quite a linear relationship, but the number of parameter explosion makes this important in two senses. The first sense that it's important in is that it can learn way more complex relationships between what it is, the task that we want to do. So the number of parameters sort of dictates the number of the amount of complexity in the underlying model. But additionally, if you have such a high parameter model, it also becomes harder to train these models. You need much more computing power as well. Which is why most of what we are going to do, you're going to run some bits of it locally, but a lot of it is not going to be run locally. It's going to be run on the cloud, which is where the implications towards your research might become relevant. I know that I'm working on a project partnered with industry partners, and they cannot use GitHub Copilot for exactly this reason. We've been trying to sort of see if we can integrate Llama, which is another an alternative to ChatGPT, which is the more sort of popular one. And then in 2020, we had we had GPT-3, which had 175 billion parameters. So it's just, it was not just the number of parameters, it is also some sort of fine-tuning within the model itself. But primarily, this is the sort of the way that OpenAI has evolved its underlying model. But these were also more generic tasks, and if you've used ChatGPT at all, or if you've seen the first generative AI tutorial, you've sort of seen how broadly sort of applicable these things are, and you can ask sort of Q&A for it and things like that. But one of the things that they noticed was that even though it was not explicitly programmed to do so, it was actually fairly good at generating code. And so what they did was they took that idea and took it one step further. And in June 2021, GitHub announced GitHub Copilot. GitHub Copilot is a specific tool that you can sort of use alongside your IDE. There are specific IDEs that you can use alongside GitHub Copilot, and it essentially does like code completion for you. Now, if you have, so IDE is an integrated development environment. It's basically the editor that you use for coding. If you have used an IDE, you've probably noticed that when you use the IDE, there's a bunch of completions that it provides for you. GitHub Copilot takes this one step further. So rather than just looking at, what kinds of packages you can import if you're using Python, then, what kind of packages you can import, or what kinds of function definitions you want, it actually takes it even further and provides multiple such definitions for you. So I'm going to show you, broadly speaking, what kinds of things you have available through GitHub Copilot. Primarily speaking, it's OpenAI's ChatGPT, sort of, combined with all of the publicly available data on GitHub. So GitHub is this sort of code repository where anyone can create code, and many of you probably use code. Through GitHub, a lot of the papers that are published in the ML sphere, for example, we have almost all of our conferences now have associated code that's published, and that's publicly available. And typically, it's provided through this code repository called GitHub. Now, the cool thing about that is that you have access to all of this amounts of code. The tricky thing there, and this is what I want to talk about when I talk about the legal implications of it, is it's not entirely clear whether you can use that code for for-profit things. And one of the reasons that this becomes tricky is because technically speaking, even though we have free access to Copilot is not a not-for-profit thing at all. In fact, you actually do need to sort of subscribe to it. I think it's like $10 a month or something like this at this point. So we have OpenAI, which sort of use this GPT model, which is specifically related to coding, called Codex, and I'll provide an interesting paper about Codex at the end of this in my list of resources. And then we have this Codex sort of combined with publicly available code from GitHub. What GitHub Copilot allows us to do is essentially suggest lines of code as you type, as well as functions. So you can start off a function definition, and it will sort of provide the rest of the function for you. You can provide prompts in comments. So prompts are essentially ways in which you're asking the model to complete the sentence. And so you provide these prompts, and the rest of it sort of just gets populated for you. So there are three kinds primarily of examples that they sort of highlight. The first kind of example I think is the least impressive. That's this one. Where it essentially suggests just single lines of code. Some of this looks so familiar from using IDEs. This is a functional representation, and I'll say a little bit more about this in the next slide. But so you specify a couple of dates, and then you're sort of trying to figure out the difference between those two dates, and it's sort of able to figure that out sort of automatically. And then this bit is what we're going to focus on most, because I think it's the most sort of interesting and potentially useful aspect of it. So this is where all we've done is told it, load, survey, and clean up data, and it automatically sort of produces these three lines of code, which actually, pretty much, well, maybe not the second line, but we'll pretty much sort of look through this set of code. So if not everyone is familiar with Python, I think it's fairly easy to read Python. So that's what I'm going to be using as my example. But it's not the only language that you can use with Copilot. All right. So how does GitHub Copilot work? So this is actually from their blog post. There are a few things here that I want to sort of call our attention to, and I promise that it's interesting, but it's really not the focus of today's talk. So I'm actually going to focus more on how it affects the way that we use Copilot, as opposed to how does Copilot work. Which knowing a little bit about how Copilot works is definitely going to be useful. but it's not going to be the focus of what we do. So first of all, GitHub Copilot, it's not publicly available. How exactly their exact model is not available. GPT-3 is available for us to read and understand, but ChatGPT, the exact ways in which it works, it's not clear. Even folks who work within LLMs and sort of understand LLMs well do not understand why these models work as well as they do. So I was at a talk recently where people actually admit this, like, who knows why this is working the way it does. It also means that we need to be super aware of places where it can completely fail. And so I want to show you one particular example that I thought was hilarious about how it fails. But anyway, so here are a few different things that I want to sort of point your attention to. So this prompt library, it's effectively what they say that they have access to, which is a bunch of different, the way that we'll be interpreting it, it's effectively a bunch of different comments from other users that have used, let's say, Python. So other users that have used Python have comments, and then they have code. And so what they're going to try and do, what GitHub Copilot is going to try and do, is when you specify a comment, it's going to try and figure out who else has written code that looks kind of like this, and then it provides a bunch of possible suggestions for you to pick and choose from. So the main part of this, I would say, is prompt engineering. And I'm going to do something very brave. I am going to do a live demo. And the reason that it's brave to do a live demo is because unlike where, I can write bits of code and things, unlike that, I have no way of knowing if the specific prompt that I used yesterday and the day before and whenever I was preparing this talk is going to produce exactly the same set of code. In fact, it's very likely not. It's not going to provide the same set of code. But what I figure is that if it messes up too much, I have PDFs of what worked. But also, I think places that it fails can be very illustrative. And so I thought, I'll be brave and I'll take that chance. Okay, so here we have. So that's the prompt engineering part. How do we ask a question in a way that it can understand and know, therefore, which bits of code are most relevant to me? That's prompt engineering, and I'll say a little bit about that. Where's my, oh, there it is. The other bit of this is, you'll notice here, this contextual filter model and this thing, open tabs. Both of these things are effectively context-based. So you have the prompt itself that you're specifying, but other than the sort of localized prompt that you're specifying, you're also specifying things implicitly to Copilot. And the way that you're doing this is by keeping a bunch of tabs open. All of these tabs may have code that are related to the code that you're writing. And so it's able to then use that as ways to sort of bump up certain suggestions because it seems like it's around the same space as that you're interested in writing code for. The other thing, so that's the, that's the neighboring tabs bit. And then there's the fill in the middle paradigm. This is effectively just context. So if you have a prompt right in the middle of your code, it essentially looks at stuff that came before and the stuff that comes after, and then tries to do a mapping based on that. And then there is this, what they call vector database, which it turns out is just a high-dimensional embedding applied to. So when we look at different types of code, we can look at whether the form looks the same, so whether the syntax looks the same, or we can look at, does the meaning actually match? Are they similar in meaning? We do this in natural language a lot. What they're trying to do is apply this to code as well. So they're saying, we're going to take every bit of code and apply high-dimensional embedding to it, and look at bits of code that sort of lie close to each other to sort of construct some notion of similarity of these bits of code, and then use that to provide completion. But this is from their blog post. GitHub blog says it all comes down to prompts. So what I'm going to be focusing on is primarily prompts. I mean, keeping bits of, the tabs open, I think is fine. But I found that actually the prompts matter a fair amount. All right. So here are a few best practices for prompt engineering according to GitHub. And I've added a little bit of my own sort of twist to it. First, let's start with a high-level goal. So one of the things that I would, since we're going to be using a Jupyter notebook, I'm actually going to sort of start off with, well, I'm going to say this is a sample notebook, but you can actually write out your, your topic of like what it is that you're trying to analyze up top. It does help. Sometimes it veers off the deep end and gives you like really not relevant suggestions. But if you tweak the language a little bit and you sort of specify it in a particular way, this is where you're sort of providing context to it. So the high-level goal first. And then when you're asking questions, this is something I have found. For example, keeping it as simple as possible. Telling it, just get me the URL for this data set. Super helpful. It'll give it to you. This way, it saves a lot of typing. If you, on the other hand, just say something like, build a classifier to classify handwritten digits, it may or may not give you what you actually want. If you're specific, so if you're using, for example, a deep learning model and you tell it, I want to build a CNN, that's not great. If you tell it, I want a CNN with 2 convolutional layers followed by 2 fully connected layers, that's much better. It's able to do a much better job the more specific you are. I have noticed that if I tell it plot something, it may or may not provide the right kinds of plots. If, on the other hand, I say plot something with matplotlib, then it'll do a much better job. So specifying the packages that you want to use, specifying as much of the information as you possibly can, turns out to be super effective. I think that if you're telling it to train a model, again, it's much easier if you tell it, first load the training data. Oh, first load the data set. Split it into training and test. Then tell it to train. If you tell it in these sort of sub-steps, it does a much better job than if you just say train the model. Sometimes train the model does work, I should say, but not always. The other thing that I notice is that after each prompt and each completion suggestion, it actually helps to execute that step. It makes a big difference when you execute that step. Sometimes when you want the plot to sort of include multiple things, it actually helps not to execute that step, but I'll show you a couple of examples where it helps and it doesn't help. But primarily speaking, like if I had to specify a rule of thumb, it would be definitely execute things. I have found that different ways of asking the exact same question, which from our purposes sounds very similar, might yield very different results. So this has been super helpful. If you know what you're looking for and you're just trying to extend it beyond what you have, giving it one example and then having it generate multiple examples based off of that first example is very helpful. And it is helpful to keep a couple of relevant tabs open, especially if you're working through a slightly larger data set. All right, so any questions so far? Anything that was unclear? I will get to the fun bits of like working through the thing as well. All right, so there are a few IDs that we can use. Visual Studio and Visual Studio Code, both I know are available through U of M. I've used Vim at some point in the past, but I've not used NeoVim, so I cannot speak to that. I will tell you a little bit about Visual Studio Code, but it's not great news. But if you're familiar with Visual Studio, I think that should be fine. I use JetBrains IDE, and in particular, I use PyCharm through JetBrains IDE. Now, I'm in the computer science and engineering department, and we have a Department of Computing Organization, I think, DCO, which is our ITS arm, and they are fantastic. Like when I refreshed my machine, they already had this installed for me. So I didn't have to go through the pain of installing JetBrains IDE. So what I did was for this talk, I actually went through some painful process, and I went and like downloaded Visual Studio Code to see how painful is it to actually get this running. Turns out it's not terrible. It's not super easy because sometimes like I have multiple versions of Python on my machine, so telling it where to find things and set the path can be a little bit of a pain, but it's not super difficult. So I did a couple of things. I went back and I looked at how would you, if you wanted to use PyCharm, which I would recommend very strongly, but I'm biased. I think that you can go to the U of M software directory. Again, I know Ken mentioned that these slides will be available, so these are hyperlinked, and you can click on that. It's effectively available for everyone. PyCharm is part of this. PyCharm is part of this here. And I had Anaconda installed, so I had like a bunch of other things that came along with it. PyCharm has a quick start guide, which I think is fairly nice. If you have it installed correctly, you should get the professional version. I think there's another education version, but U of M allows us to use the professional edition. I think you have to renew the license annually, to show that you're still affiliated with the university. But that's the one that I'm going to use. I'm going to use the professional edition of PyCharm. You also need to install GitHub Copilot. Most of you, I'm guessing, if you're in the session, you're using code, and so most of you probably have access to GitHub. You can request GitHub Copilot through your GitHub account. The only thing that they ask for is proof that you are affiliated with a university. So if you go to GitHub Education specifically, you can request GitHub Copilot through that. And you have to select your academic status. You can select either student or teacher, and teacher is fairly loosely defined. It's defined as an educator, a faculty member, or researcher, which I think pretty much encompasses everyone in this room, at least from the registration list that Ken kindly shared with me. And what do they mean by proof? I was uncomfortable giving them my UMID. And so I just looked at my CSE faculty webpage, the directory listing. I screenshotted that, and I think they said that you needed to also put the date in. So I just screenshotted that bit and sent it to them, and that seemed to be fine. So I imagine it's not going to be super painful to get that. Maybe your M community listing might be helpful as well. So just to be clear, so we have PyCharm installed, and then you have an account from GitHub Copilot already active. I think it took about, I want to say it only took like 2 days. They say it takes about 14 days, but it didn't take very long at all. And then once you have both of these things active, so you have PyCharm installed on your local machine, and you have an account from GitHub Copilot, you have to sort of make them talk to each other. And so for that, all you have to do is go to this plugin, go to the marketplace, and install, search for Copilot, and you get pretty much just the first hit is GitHub Copilot. And it sort of asks you to sign in as well. It was fairly straightforward to walk through these steps. This is what it looks like in PyCharm for Mac. Once you open PyCharm, you can go to Settings in PyCharm. And in Settings, you can go to Plugins. And within Plugin, you can go to Marketplace. It's important that you sort of select Marketplace here. All right. And then if you install it, it's going to keep giving you suggestions. It's going to keep sort of pulling suggestions from Copilot. So you would probably want to know how to disable this. I think it's always important to sort of know that. But if you see right here up top, it's really difficult to see. But it says GitHub Copilot up top there. Right here is a little icon that also represents Copilot. If you click on that icon, you get these suggestions. So you can either disable completions for Jupyter. This is a Jupyter notebook, or log out from GitHub. All right, so the other thing that we'll be using is the Jupyter notebook. And to install any packages, it's fairly easy to install packages in PyCharm. So if you see down here, bottom left, you'll see Python packages. If you click on that, it actually sort of pulls up all the packages that you have installed already. Now, I already have Jupyter installed. I searched for TensorFlow, which I did not have installed because I primarily use PyTorch. If you search for TensorFlow, or whatever package it is that you want to install, you just get this sort of install button. It tells you what the package is about, and it's a fairly easy process. If you haven't used Jupyter Notebooks, I would strongly recommend it. It's just a lot of fun to work with. It's hard to stop once you get it going. So. All right, so once I'm within I sort of open a Python project within PyCharm. I can then create a new notebook by right-click, selecting New Jupyter Notebook. Now you'll notice here that this is the neat bit about Jupyter Notebooks. So these things are called cells. You see how it says in one? That just means that this is the first input in that Jupyter notebook. So I've already created a Jupyter notebook. I'll walk you through an example of that. This hash is a tag that represents a heading in Markdown. And if you just Google like Markdown syntax, you'll get like a bunch of different pages. And really, I think like you should know how to use bold, you should know how to use italics, and then you should know how to use headings, because that's pretty much all you need to make a very readable document. So I've put hash learning about data science. I'm going to change the type of the cell. So the cell is currently, like the default cell is a code cell. I'm going to change that from code to Markdown. And then I press Shift and Enter in Max, and I get it compiled as a heading this way. So this is so far, nothing that I have said has to do with GitHub Copilot specifically. This is just how cool Jupyter Notebooks are. So I'm going to use Jupyter Notebooks and then integrate GitHub Copilot in this. Here is where GitHub Copilot sort of says, if you're doing data science, you probably want to use pandas. And the first completion that I get is import pandas as PD. Pandas essentially just allows us to read tables, which we'll see in a bit. All right, so what else can you do with GitHub Copilot? You can do simple Q&A. So here's a simple Q&A. What is a CNN? Now, again, I just put hash Q, what is a CNN, press enter, and it offers the completion. So this is my prompt. It offers the completion. Answer a convolutional neural network. That's great. Then I pressed enter twice. I did hash Q, and it automatically completes and asks, what is a neural network? Because this person seems to want to know a little bit more about CNN. So don't look at that yet. Okay, so you do Q. Okay, so what is a neural network? And it says a neural network is a series of neurons that are connected to each other. I didn't think this was super helpful, but I imagine that if you're just, refreshing a memory or something, that might be helpful. The next thing right here was actually pretty helpful. It said, define a neural network. And then you see on the right-hand side, these are all the completions that it offers. So each of these code blocks right here is a separate completion. Up top, above every code block is this button that says accept solution. This is just, Q&A, further Q&A. So it's imagining that you might just have a bunch of Q&A for it. or it's imagining that you might actually want to define a neural network. And you can sort of scroll through. Now, one thing I would strongly recommend is not just accepting solution. If you accept solution, this thing that you're seeing right here is not all that it actually has. You can scroll down, and it's like pages of this potentially. Sometimes, and this is an artifact of LLMs. Sometimes it'll just repeat itself a bunch of times. So the same code in multiple ways. And I'll show you an example of where this might actually happen. So I would recommend instead selecting just the parts of it that seem relevant to you. Now here is an example of where it can completely go off. So ask, what's data science? Study of data. What's data? Data is information. What's information? Information is knowledge. And then what is knowledge? Knowledge is the understanding of information. This completely went off the deep end. I don't know if you've seen examples of ChatGPT, but sometimes if you ask it questions, it'll sort of make stuff up. That's called the hallucination effect. It's effectively hallucinating ideas for you because it thinks you want to hear about something, and it thinks its goal is effectively to give you information whether or not it's factual. So what does this actually show? Well, A, it's funny. And second, I think what it shows is that how you specify the prompts matters a whole lot in what kinds of responses you get. So the design of these prompts turns out to be fairly critical. So that said, I am actually going to do one, this is the live demo that I'm going to do of data visualization. So I thought I'd focus on fairly sort of, broadly appealing data sets. The first data set that I'm going to look at is stock market data. All right. So I'm going to open PyCharm. I am going to open a new notebook. I'm going to call that Midas example 1. All right, so as I mentioned, this first cell that I just created, this is a notebook now. I want to make sure that GitHub Copilot is active. Yep, that seems to be active. There's the right-hand side with the GitHub Copilot here. This bit right here says code. I'm going to change that to Markdown, and I'm going to say this is, oops. All right, this is a sample notebook. I don't know if you saw this. So these completions are actually coming from GitHub Copilot. I don't want to accept any of those completions. I'm going to do, oh. I'm not sure how I'd be able to do that. Yeah. Is that better? Sorry about that. Okay. So this is a sample notebook. I am actually going to ignore the rest of the suggestions. I'm going to click. So again, this thing right here, unfortunately, I don't think I can increase the size on that. Or maybe it did increase a bit. Anyway, I selected Markdown here. Okay. And then I'm going to do Shift Enter. And that makes it a heading. Now, this already knows that I've been working a lot with pandas, and so it's already providing this as my. Actually, I take that back. I think the first time I did this, also it sort of assumed that I was going to use pandas. So I'm going to do tab. Tab allows me to sort of accept that suggestion. Another thing I could do. Okay, actually, let me accept the suggestion. I'm going to Shift Enter. Now you'll notice that this thing is grayed out. The reason that it's grayed out is because this particular IDE is sort of interpreting to see whether or not I have used that particular package. Now in this case, I haven't used the package yet, so I'm going to leave it as is. And then I am going to put in a new subheading. Visualizing stock market data. All right. Now, if I did this, it wouldn't quite work. So I need to first tell it to get a CSV. So I'm going to say get URL for stock market. There we go. Now, again, I want to show you that again. So I did get URL for stock data, okay? Stock market data, that's much better. So every time it's italicized, that's not me typing, that's GitHub Copilot providing a suggestion. I pressed enter here. I did not press shift enter because I wanted to actually use that as a prompt and generate something. And in fact, here is something that it generates. So I'm going to select that and press shift enter. Okay. The next thing it's prompting me is to read in the data. I'm going to say read in the data using pandas. That's even better. Again, I said read in the data. And then this is the completion that it's offering. It's offering the completion of using pandas, which I'm going to accept by pressing tab. Okay. And this is where it's actually reading that particular URL, which is great. So I'm going to do shift enter so that it executes that. And you'll see actually that it's actually executed that. Okay, that's too big. All right. The next thing it's suggesting, which is exactly what I wanted to do, is view the first few rows of data. So I've read in the CSV file, this essentially like an Excel sheet, right? I've read that in, but I want to see what it is that I've read in. So I'm going to say, yes, I actually want to do that. df.head is a built-in function that does that for me. So it'll just give me the first 5 rows, I think, of the data. So I'm going to shift enter, and there it is. Now, I want to point out again, I think it's really cool. So I just put in those comments. I did not write anything that are not in comments in each of these blocks. Everything that was outside of the comment section is just this, automatically completing it for me. All right. Now, what it's saying is not what I want to do. Instead, what I want to do is I want it to plot the data using matplotlib. Okay. So I'm going to import matplotlib. I'm going to plot just the high prices. So what it did was it took date as my x-axis. It took the high prices as my y-axis, and it plotted it for me. And this is where it might get tricky, because yesterday I tried something slightly different, just like a slightly different wording, and it didn't quite work. So let me see if it works. Plot the open and high prices. Let's see if that works. That's high. That's open. Okay. So I don't like that. Because, okay, so if I did this, it's just going to plot this, which, it's not super helpful. I don't know what orange is. I don't know what blue is. And so I'm going to say again, plot the open and high prices with legends. And that's much better. So this is the sort of iterative refinement I was talking about. And also, it's very, very specific. I'm telling it specifically, like, I want to plot this thing. I want to use matplotlib. I don't want to use plotly. All of these things. You do have to specify to it, but it essentially saved me I want to say it saved me like 60% of typing time. I also don't need to necessarily remember all of these different packages. I don't need to remember the specific hyperparameters, and that becomes even more relevant as we go into more and more complex models, machine learning models. So this is just the okay. This is actually asking me if I want titles as well. So that was my first example. Any questions on this? So again, all I've done is plotted like line plots of it's fairly simple and hopefully fairly sort of generic that you can actually apply it to your specific sub area. All right, so the next thing I'm going to do is, because I like this data set so much, I'm going to use the Penguin data set. Again, I'm going to make it marked down. Okay. And it's telling me I want to get the URL for the Penguin dataset. Again, I haven't typed anything. It's sort of from context, from what it saw before, from what I did before, it's already sort of figuring out this is what I want to do. So I'm going to do tab, enter, tab, enter. Read in data using pandas. It's exactly what I want to do. Tab, enter. Tab, shift, enter. View the first few rows of data. That's great. Tab, enter. Tab, shift, enter. And you'll see that it has, the species, the island, the bill length, bill depth, flipper length, body mass, sex, and year. And so I am going to, what's the first thing I want to do? I want to plot the number of different islands. Plot the data. So this is interesting. The reason it's telling me this is because I did exactly these steps in the previous example. I don't want to do that quite yet. Instead, what I want to do is I want to plot the number. Nope. Okay, fine. I want to plot the number of penguins by species. It's not quite what I want to do, but I think it should be fine. All right, and I do shift enter. This is what happened yesterday too. Now, if I was just like, accepting and moving forward, I would be probably a little confused by what happened, except that if you'll notice, species here is lowercase, and here it's uppercase. So I'm going to fix that. So this is where you cannot completely trust it. Part of it was the first time I did this example, it actually pulled this data set. So there are multiple penguins data sets floating around on the internet. And in one of them, it was called bill length. In another, it was called culmen length, which I believe is, I know they're probably biologists here, but I believe it's fairly similar. And it was not clear to me, so I didn't actually, have it sort of specify the features and things like that. I was just accepting it. And I wasn't sure because I had seen the culmen length one before. And so I wasn't sure why it was not working until I went back and looked at this specific data set, and turns out the features are called slightly different things here versus in the other data sets that were available. I just thought that was interesting. So in other words, we cannot be totally blind to what it is that we're doing. On the other hand, we can actually use it fairly well as a completion engine. Anyway, so I wanna do some machine learning as well. So my first thing that I'm going to do here is learning a decision tree classifier for not the iris data set, but the penguin data set. Right, I'm going to change that to markdown. Fine. I'm going to import the decision tree classifier. Create a decision tree classifier. I don't know what it's going to do. Let's see. Okay. Create a list of features. Yep, that's important. create a list of target variables. That's what we're trying to predict. Species, that makes sense. Create a new data frame with just the features and the target. Yep. Drop any rows with missing values. That's important. That's the NA bit that we saw in that example. Yep. All right. Create a new column called isFrame. I don't want to do that. Instead, I'm going to say split the data into training and test sets. Fit the model. That's good. Make predictions. Calculate accuracy. And, you know, it's not surprising. It's a really small data set. It got a very good accuracy. And then I actually want to say visualize the decision tree, because I think that is helpful. Oh, okay. Well. And that's my decision tree. So one of the things I forgot to do earlier was, so it knows this because I did this yesterday. But I set the max depth, so it's not so difficult to read. But really, it's not super critical that we look at exactly what it's learned. It's more important that we can actually get these things to work fairly trivially. And so that's my first example. I have a couple other examples, but rather than going through them one at a time, I'm actually going to show you the PDF. So this is the other cool thing about notebooks. I can, oh, sorry, yeah. No.
Is it hard to do things like group stuff? Like, for example, cross-validation instead of just...
It's actually not that. I'm going to show you a couple different examples that are more yeah, you're right. This is like fairly trivial. But it can do fairly complex things. I want to say that the more specialized it gets, like I tried to use GradCam, and it really struggled with that. On the other hand, it was able to do visualization. I'll show you an example of that. So, yeah, thanks for the question. All right. Let me... So that was, and maybe can I allow also?
I have a question.
Oh, sorry,
like,
yeah.
I noticed that you removed the missing data rows.
Yeah.
Is there a way to deal with it or imputate or anything that you can do?
Absolutely. So the reason that I removed it is simply because I didn't want it to get stuck. So in this case, I think it'll be fine, but I think when we use like regressors, for example, if it finds not a number, then it starts complaining, and so you have to go back and sort of drop those rows. I think when I did SVC, I had to drop those rows. Yeah, in general, if you're using like it in practice, it depends. It depends on like how. There was one row there that was like super sparsely populated. Let me see if I can find it here. Yeah, like this one. Now, if you have a row like this, I don't know if you want to impute. It depends on the application, but you could impute the data. But you can see here, it basically has nothing available except the species and the island, which is, I don't know how helpful it will be.
Set the percentage of missing data, like maybe that row.
Exactly. That would be one way to do it, like to count the number of features that are missing and then drop only those. Yep. Yeah. I just accepted the suggestions that Copilot had, but it's absolutely not the only way to do this. Yeah.
So you made a comment about the next step. Are you saying that Copilot was learning your preference, or that's something you were...
Sorry, can you say that again?
Were you suggesting that the Copilot was learning your preference, or that you already specified the max depth somewhere?
I had already specified max depth before. So in another... And so the answer to both your questions is actually yes. It is learning my preferences, and it is learning it from other notebooks that I had actually opened in the past to do exactly this kind of bit.
The code you generate doesn't specifically say.
No. So sorry, I should have been clearer. Hold on. So in the code that I wrote, accepted. I didn't really write this code. So in the code that I accepted, the max depth was not set at 2. It was, fairly noisy looking. not noisy in the technical sense, but like fairly sort of not great looking decision tree. When I set max depth, then I can see the decision tree really nicely. I think I had done that in my example before. Let me see if that is true. No, yeah, here's in fact, I have set a max depth. I think this is 3. So it's, it's easier to see, it's easier to visualize what's going on. If you set a max depth, the good thing is, you control for overfitting in real problems, you control for overfitting, but you also sort of are able to sort of interpret what's going on a little easier. That's why, yeah. Sorry, yeah, if there are other questions, I think. Yes. Did you say bias?
No, I'm saying that the JetBrains, the software you mentioned earlier.
Oh, yeah, yeah.
Because it says that this software is only open to regular staff. I don't know whether that includes students.
That is actually a good question.
And when I click the download link, it asks me for credit card information.
Oh, so yeah, definitely don't give it that. So I'm fairly certain PyCharm has a student edition. If it's a student edition, I have to be honest, it's harder for me to see what the pathway would be for students, but I know PyCharm has an education version, which is available to all students, but I'm fairly certain ITS should have do you mind if we talk offline?
Yes,
so that,
sure.
yeah, and then I can look up and see if there's any specific. Thank you for the question, though. If you're looking for another IDE, Visual Studio Code might be something you want to consider, and I'll tell you why in a quick second. Because Visual Studio Code again is available for all students, and that should be fairly easy to see. Sorry, any other questions? Okay, all right. So I'm going to minimize that. I'm going to show you a couple of different examples here. Oh, definitely, I can't read it either. Okay, hold on. Okay. Right. So yeah, this is where I wanted to show off why you should use Jupyter notebooks if you haven't already. It's really nice. I mean, it's, even when I'm writing notes for myself about a particular model, I find it really helpful to have this generated as a PDF that you can refer to later. So here's a few things and this is actually related to, I forgot who asked the question about training and testing. Oh yeah, I think you did, yeah. So here is a slightly more complex model. So I'm going to use SVM classifiers, I'm going to use SVC. I'm going to use linear SVC, which is not usually what you would use, but I'm just going to use linear SVC for a couple of reasons. So the first thing I'm going to do is I'm going to take image data. So I'm just telling it to load a handwritten digits data set. Typically, you would expect it to load MNIST. So the next example I'm going to look at is MNIST specifically, but I wanted to sort of load whatever data set it had as its sort of as its first option. So here it's loading the digits. Again, all of these things in comments are what I have specified with the help of Copilot, but all of these code bits is not stuff that I have written. Telling it to get the shape of the data essentially means I just want to see, how many digits are you working with here? What does the image really look like? You'll see that x.shape here is 1,797, which means that there are about 2,000 data points. And each of those data points is represented as this 64-dimensional vector. But really, you can think of it as a 2-dimensional sort of matrix. And then each of the y values are the labels for each of these images. So what does that actually mean? Here is my first image. My first image, in computer science, we start with 0. So my first image is my 0th image, and my first image looks like this, which, I don't know. It doesn't help me a lot. So I figure, okay, that's not helpful. Instead, let's plot the first image, and that's a little more helpful. So this is 0. And then I told it to get the target of the 0th data point, which is 0. That means that this was the image, and the corresponding to this image was a label 0, which is appropriate. This is get first data again. Not super helpful. Again, I'm just like accepting suggestions here. Get first 64 data. I'm not sure. I think what it was trying to do is the next bit right here. So this is what it wanted to do. It wanted to reshape the image so it looks more like a proper matrix. And so you can sort of look at this matrix as corresponding to this image. So every cell here is represented by a number here. Okay, so this is 8 by 8, 0 through 7, and 0 through 7. So that's an 8 by 8 image, and there's an 8 by 8 array here. And again, so here's one thing that I think is kind of interesting. So you can have it show the image, but then it has a bunch of, and this is the hyperparameters that I mentioned briefly earlier when somebody else asked a question. So here are some hyperparameters, and what are those hyperparameters? I don't know. So I'm going to ask it that. What does interpolation nearest do? It makes the image look less blurry, which is sort of true, but also like not super helpful. I thought it was helpful enough, though. It gave me a sense of, okay, why is it that it's picking a particular interpolation, and then it's basically a smoothing function here for the image, and then this thing right here says, I don't know, cmap.plot.cm.grayr. What does that mean? Well, it makes the image grayscale. Oh, okay, so that means this image is not grayscale. What does it look like originally? And so I removed those two bits, and this is what we got. And this is, it's fairly intuitive to understand what's going on here. And so, and here is, yeah, yeah.
So when you have the Q and A over there,
Yeah.
do you have to be in a markdown mode?
No, this is all in, good question, yeah. This is all comments in the cell. In fact, you don't even need to put Q and A. It just, it's for readability that I put it in there. Yeah, you can just put the questions in there. Yeah, so this is in fact, this entire thing is one cell, and it's all a code cell. Yeah, so hash works as a comment specifier for Python, a line comment specifier for Python, but it also works as heading, which is what is confusing for Markdown. Right, so we plot, okay, so here's where I sort of accepted solution, and what I ended up seeing was a bunch of different, plot the first image. It's not the first image, it's actually plotting the first 3 images, but it says plot the first image for every one of these. Anyway, it was helpful to see what the images look like. Next, we learn an SVM classifier to classify the digits, and again, I split into train and test sets like before. And here is where I'm actually having it import SVC, specify the hyperparameters for SVC, fit the model for SVC, look at the score, and then look at image here. I want to say something real quick in the interest of time here. But one of the things I try to do is, when we use SVMs for classifying there are 10 possible digits, so it's a 10-ary classifier. SVM is technically a binary classification algorithm. So what it's doing is it's combining all these binary classifiers into this 10-class classification algorithm. And it uses different techniques. One of the techniques that by default it uses is one versus rest. Now, that does not allow us to interpret what's going on really well. I've used a linear kernel because I want to interpret what's going on, and this does not allow me to interpret what's going on. So what I did was I took that 10-class classification problem and rewrote it as a binary classification problem. And when I told it that that's what I want to do, immediately it knew how I would go about doing that. And it basically said, oh, so what you want to do is distinguish the digit 0 from all other digits. And I was like, yeah, great, that sounds good. So let's go ahead and do that. And here is where it actually did that. Now, you will notice that I have two, in 84 and in 86, look almost the exact opposite of each other, and it's like really doing the same thing. The reason that I put this in, I left this in, is because when I first did this, it didn't have this. This in 86 did not exist, and It trained everything, and it gave me like a 1 minus, so it was like 0.006 accuracy. And immediately I knew what happened when when I took its automatic suggestions, it mapped zeros to false and ones to true in the training data set, and in the test data set it did exactly the opposite. It mapped zeros to true and ones to false. And so unless you go back and look at the code and see where it sort of tripped up, but something simple like this, it should immediately flag for you that, like, come on, MNIST, it's like a solved problem at this point. So it should not get such a low accuracy. And so that's why I left that example there. But that's one example. And then the other example that I, again, want to go through really briefly is this one. So this is, again, digits. Excuse me. But instead of using digits, I'm actually using MNIST. Where is it? Here it is. And here is where I'm actually specifying a convolutional neural network. So it's a much more complicated model now. And now it has to actually define the different layers. Here's a fully connected layer. It has to define forward propagation. It has to define training. So it has to sort of specify both the loss function as well as the optimizer that we're using. And here is the loop that I think you asked about. So here's where it's actually having to train for each data point across multiple epochs. You can actually specify the number of epochs here as well. Again, none of this is stuff that I have written. I just told it I want a convolutional neural network with 2 convolutional layers, and it sort of added on the fully connected layer for me. I also, one thing that I did do is ask it to plot validation and training accuracy after the fact, and then I realized that it cannot do that. It cannot do that because it actually needs to keep track. So, what I wanted to do is, as it was training, I wanted it to show me how the learning is happening. So my training loss is reducing over time. My validation loss, hopefully, is also eventually going to reduce over time. So I want to see that. But to be able to see that, I need to actually keep track of this. So I had to go back and write this prompt so that it said not just train the model, but train the model and plot validation and training loss. So that's why it keeps track of this bit right here. Whoops, sorry. This bit right here, the train loss and the training accuracy, and the same thing with validation loss and validation accuracy. So then when I give it a second prompt saying, okay, now plot it, it's able to just pull those values up that it had saved before. The other thing I did was visualization. When I first asked it to visualize, all it did was give me the filters themselves that were learned, which is usually not super helpful. So instead, you can ask it to visualize a feature map of a particular test data point. In this case, I just had it pick the first image in the test set to give me, it's a little clearer on the screen than it is on the projector. All right, so I wanna wrap up my bit before I hand it off to Zhiyuan, but a couple of different things that I do want to point out. So I'll put these examples. I'll leave these examples with Ken. The ethical and legal implications. So, surprise, but there is an ongoing lawsuit against GitHub Copilot and Microsoft. So the claim is that there are open source programmers who put their code up, and people are. It's not in fact always merging different bits of code together. Sometimes it's just pulling big chunks of code from other people's work. And so it might potentially violate downstream applications of what it is that you're using. So it's just something to be aware of. Most of the time, if you're using this to understand data in your own application, I think it should be fairly fine to do. GitHub Copilot has an FAQ that I thought is important to look at. GitHub does not own the suggestions. You are responsible for it. It's basically, do with it as you choose, but it's not our responsibility. But this is ongoing, so we'll see how that sort of all shakes out. There are a few fairness and broader impact comments that they have on their FAQs as well. There are a couple of recent and well-cited papers on how GitHub Copilot works with other languages. In particular, it seems to have a lot of trouble with offensive outputs in different languages, apparently. Accessibility features are not quite where it should be yet, so that's a problem as well. And this is more relevant for my students because I get a lot of questions about that last bit. All right, so I mentioned, in fact, when somebody asked me about downloading JetBrains IDE for students, one potential option that I would have you evaluate is VS Code. Again, I don't use VS Code so much, but VS Code has two additional capabilities. It has GitHub Copilot Chat, and it has GitHub Copilot Labs, both of which are experimental features at this point, and GitHub Copilot is going to be GitHub Copilot X. And so it has sort of additional features. These features are right now only available in VS Code. I tried using the explain feature, which I thought would be the most relevant for this group, and I personally did not find it very impressive. When I looked at, I thought it would tell me, oh, it's actually, this is the input size that it's sort of looking at, and this is the, ReLU is the nonlinear activation function, all of this. It didn't say any of that. Instead, instead all it said was, I don't even know where it's looking because it's talking about defining a loss function, which is not part of the code snippet, and looping over data set of input. So not super impressive. However, if you look at GitHub Copilot Chat on GitHub's site, it's super impressive. Like their video shows you all sorts of great things. Like it has a programmer provide code and say, fix the bug in my code, and it magically, it magically produces code that's bug-free. So, yeah, I think at this point we can be a little skeptical of how well it can be used. I have a bunch of resources on here as well, but the rest of the talk, Jiwan is actually going to be talking about not using this, so not using the this in VS Code, but rather how can you use ChatGPT itself to help you do more efficient coding. But thank you very much for your attention, and I'll hand it off to Jiwan.